All right, so we're continuing on our lesson here, and what we're going to do is a little bit more intricate of problems where we're solving equations, finding values for theta that will make the equation true. So this is fairly difficult when you have sine and cosine, but it might be helpful to think about, well, what if I divide cosine over? Well, if you divide cosine over, you're just left with root 3 on this side. And in other words, what you have is on the left side, sine over cosine is equal to tangent is equal to root 3. Now, some people have to memorize the trig values for tangent, and it's very, very difficult to explain to other than memorize. But if you think about this as root 3 over 2 divided by 1/2, we've seen this before. And so it's a weird way of thinking of it, but it's thinking about where sine is root 3 over 2 and cosine is equal to 1/2. Because remember, tangent is sine over cosine. And if you did the arithmetic backwards, it's equal to this. But I do recognize that this is difficult to think of it this way. So there's a lot of teachers out there that just say, just memorize that tangent's either root 3, it's 1, or it's root 3 over 3. The other scenarios would be 0 or undefined if it's on the unit circle. So I do recognize that that's a fairly difficult problem to think of. So we're on the unit circle to sine equal root 3 over 2 and cosine equal 1/2. Well, it's this ordered pair. And I prefer my answer in radians. I think you've seen that over and over again. But this is at pi over 3 radians. So theta could equal pi over 3. But also, don't forget that tangent is also positive where sine and cosine are both negative. And that would occur in the third quadrant. Or you could just add 1 pi to pi over 3. And you would establish that it's at 4 pi over 3 because tangent repeats every pi radians or every 180 degrees. I was thinking of explaining something else to you guys about how you can write a general equation, but I think I'll save that for a later unit. So let's move on to the next one where it might be to your benefit to rewrite this problem as 4 sine of theta equals 1 over, because cosecant is a reciprocal of sine. Now be careful with this, because every year I teach this, what some students will do is they'll just cancel things out and then they'll say, oh, I'm good. And you can't really do that. What would be to your benefit would be to multiply the sine over. Think of this as cross multiplication. I don't know if anybody likes to see the cross multiplication, then you can put that over 1. So the cross product of the other side would be 1. But then from here, there's 2 different ways of thinking of it. Like some people will divide the 4 over and then square root. Let's just do that. Let's do it that way. That's usually easier for students. So divide the 4 over, so you have 1/4. And then when you square root, it's very important that you recognize that when you square root, when you're solving, you get a plus and a minus. The square root of 1 is 1 and the square root of 4 is 2. So what's so important about this is that you want where sine is both positive and negative, because if you go back to this problem, if sine is negative, well, cosecant is negative too, so they'll still be equal to each other. In the same manner, if sine are positive, so is cosecant, so they're still going to be equal to each other. So think about the unit circle for a second. Sine is the y-coordinate, so we care about where the y-coordinate's 1/2. That's at root 3 over 2 1/2, which is pi over 6. And then again, it's positive at 5 pi over 6. It's negative in the third quadrant, 7 pi over 6, and then 11 pi over 6 in the fourth quadrant. And now we've answered all places where sine is both positive and negative. I'm sharing the answer key with you just because I want to make sure that you understand that what I'm really doing is I'm finding the angle by doing inverse sine, but because these are points on the unit circle, then I can think of it slightly different. So there's no need to go to a graphing calculator or just a scientific calculator for that matter. So my work is slightly different, but it still works out. So before moving on, it's just a reminder that you can factor, because this last problem that we just did, I talked about how you could divide the 4 over in square root. There's another way of doing that, because if you notice, what I could have done is I could have subtracted 1 to the left side, which is what this first problem is looking like. And the whole premise is that we can factor problems with sine and cosine if we think of them as just variables. Like if I asked you to factor, let me just start with 4x squared minus 1, I hope you would realize that that's a difference of squares, as the square root of 4x squared would be 2x, the square root of 1 is 1, so make 1 plus, make 1 minus. Could have done the same thing on this one, and before doing that though, I want to point out, notice that these answers would have been negative 1/2 and positive 1/2, which is exactly what I did up here in this green. So what you need to recognize then is, instead of writing x, we have sine of theta. So I hope it makes sense, and if it doesn't, please bring it to my attention that it's 2 sine of theta, 2 sine of theta. Now when I multiply those together, I get 4 sine squared of theta. 1 times 1 gives me 1. To make it negative though, make 1 plus, make 1 minus. So notice the similarities between these problems. I just took out the x and replaced it with sine of theta. So as we move forward to some other problems, it could be greatest common factor. It could be factoring like they're trinomials. There's so many different things. Like on this one, as I'm looking at it, I would factor out a cosine. That's shouting out at me. And then I'd have sine squared of theta minus 4 cosine squared of theta. That we could then factor. That we could have a difference of squares embedded within that. Now, there might be other ways of doing this problem, so that's why I kind of stopped for a second. Where maybe you rewrite this as sine of theta times sine of theta gives me sine squared. And then 2 cosine times 2 cosine gives me 4 cosine squared. To make one negative, one has to be plus, one has to be minus. So there's a lot of different things you can do with that. Could have even done that on this one, where we have a difference of squares. Sine times sine, with a difference, it will make 1 plus, make 1 minus. We could also do that with a trinomial. Like if I asked you to do x squared minus 2x minus 15, I'm willing to bet that most of you, so there's a little scratch work, would be able to figure out that that factors as x minus 5, x plus 3. Well, the difference though is we don't have x's in the problem, we have sines. Well, the answer is pretty much the same thing, except instead of x, it's sine of theta minus 5 and sine of theta plus 3. There's a lot going on. And I could say the same thing with this tangent down here. There's a little bit more work to be done because a lot of you are familiar with doing that 4 times negative 3 first. And then factors of that add to be 1 would be 4 minus 3. So with practice, I'll let you work through this on your own. Because I'm a fan of guessing and checking. And then this would be 3 and 1. And in order to make this work, I'm going to make this one minus, this one plus. So I'll let you try to factor that on your own and double check that you get the same answer as me. And we can do the same thing with these to the 4th powers, as long as it follows this pattern. As I'm looking at this, well, I honestly wouldn't even write 2 of them, because I'm familiar that it's going to be cosine squared of theta plus 1 quantity squared. Which, remember, being squared means you're multiplying by itself. So you could have written it twice, and you'll see that it does work out. Or you can work it out on your own. I wonder if the answer key is any different. I'm just going to that up just to see if he explains it. Yeah, he kind of explains it a little bit more. Same thing with these two down here. He explains it a little bit more than I do. But yeah, I think I've touched base on everything I needed to on that. Feel free to pause or rewatch or write down your questions and bring your questions to me. I don't know your questions if you don't ask. So why do I ask you to do that? Is now we can get into solving trig equations. And the main thing that you want to do with solving, just like when we solve quadratics, is we want to set the equation equal to 0. So now, and if you need to, I've had students in the past, and I'm not offended, they go back and they rewrite it in terms of x, and they factor that first, and then they go back to the problem and say, well, instead of x, I need to write 2 sine of theta times sine of theta. That's how I'm going to get sine squared. And now I need to get, oops, that was wrong. I'm sure some of you are questioning, why'd you write +1 when you're supposed to subtract it over? You're absolutely right. I should have subtracted over. There's only one way to get 1. That's 1 times 1. Now, how do I make it -1? Is one of these two have to be negative. So as I'm guessing and checking, I'm going to have 2 minus 1. Okay, well, that's positive 1. So let's make it -2 plus 1. -2 plus 1 as I FOIL. So how is that going to help us? Well, if I set the left side equal to 0 and subtract 1 and divide by 2, and then the right side, set that equal to 0 and add 1 over. Now I can just look on the unit circle. Okay, well, where in the unit circle does sine equal 1? That's at 0, 1. That's at pi over 2. And then where does sine equal -1/2 in the third quadrant? At that ordered pair, -√3 over 2, -1/2. Well, that is at 7 pi over 6. And don't forget about also in the fourth quadrant, 11 pi over 6. And those are our 3 answers that work for that problem. Notice that I do want all of the answers bigger than 0, smaller than 2 pi. For whatever reason, this author doesn't want 0, but he does want 2 pi. Which most math books go the other way. All right, I think I have enough time for the next one, because you're just using a double angle formula. Well, what is sine of 2 theta equal to? Well, it's equal to 2 sine of theta cosine of theta. I hope you're okay. I'm going to do 2 steps at once. I still want to set it equal to 0, so I'm also going to subtract sine of theta over. This is where I need to be careful, because a lot of students I've talked to, they want to just divide by sine. Well, if you divide by sine, you're excluding a value. It's better if you do the greatest common factor to factor out sine of theta, and you have 2 cosine of theta minus 1. There's a way around it, but I don't like teaching it that way. So your zero product property, so sine of theta equals 0, or 2 cosine of theta minus 1 equals 0, or it's saying that cosine of theta is equal to 1/2. So where does sine equal 0? Now, this is where I'm going to have a discrepancy, because I would prefer seeing that theta equals 0, because most math books will write including 0, not including 2 pi, but for whatever reason, this person writes it the other way, excluding 0, including 2 pi. So technically, the first time that sine equals 0 is at pi radians, and then at 2 pi radians. So I'm just going to agree to disagree with the author, but I'm going to follow the directions. So I'm just going to write, math books would write 0 instead of 2 pi. I need to hurry up. And think about where cosine equals 1/2. Well, that's up here and also in the fourth quadrant. And that's at pi over 3 radians. And in the fourth quadrant, that would be 7 pi over 3 radians. And I'm at my time, so I'm going to see you in another video to finish up these notes.